first this top layer, and then we got to a deeper layer, and then a deeper layer, and then a deeper layer. So that's what I'm going to show you right now.
What do you mean by it was not cut completely straight?
So if you, these are all in a plane, right? These features. If you cut that plane slightly, into the chip instead of completely parallel,
right,
then you'll start cutting deeper into these features. So you can see that these features that are up in this top one start getting fainter and fainter until eventually they become these features. And these features get sharper and sharper. And then if we go to the next image, you can see that these features, which are still here, start blending away, and then you see these features, and the neat thing to note here is this structure here, which then, when we go even further, starts to fade away, and you start to get these sort of H-like structures. So,
this is all in the same cross.
Right. So these images would line up. This one would go to the right of that one. This one would go to the right of this one, and this one would go to the right of this one. And so we were panning across. And what this really showed us was these chips are designed on an incredibly integrated level as far as their 3D structures, because you can see that there is some really neat 3D architecture going on here, because we were able to cut through different layers that are very small distances apart and see totally different features, but yet you can tell that they're all part of the same structure. So we were just really amazed at how much architecture there is in these chips.
Okay, well, like Jeff said in the last slide, a lot of the structures that we saw under both optical and SEM were kind of just jaw-dropping
was very challenging to focus at high magnification, so we don't really know what these features are because we couldn't get any closer and still maintain resolution. But in general, the important thing to take away from this is that these capacitive trenches are really big compared to the other architectures we've seen.
Also in DRAM, you can only see a couple of capacitive trenches right here, but DRAM generally has lots and lots of these. We just happened to pick a area that they were very few, so you can see them clear.
Yeah, there were other areas where it was just like trench, 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 like one after the other for probably a stretch of 10 to 20 microns, and then there'd be a little break and then another stretch.
So these are some, well, as I pointed out earlier, um, there were some little capacitors that you could see on the backside of the chip. When I was looking at the Pentium 3, I noticed that there were these structures on the backside of the chip that looked like this. So I decided to zoom in on them, and it looks like this. It's very cool because you have these interconnected planes that are sort of finger-like. So half of them are connected to the right side, half of them are connected to the left side, and then you have insulation in between to store the charge. So
That image is a zoom in of what part in the first image?
This is on the right side.
It's a cross section of these capacitors here. Okay, so if you sliced it, I believe it's this way.
yeah,
If you sliced it along this cross section, that's what
you
you're
get one of
seeing.
these.
Oh, okay.
And then this is what happens if you zoom in again. It would be like this corner of it. Zoomed in more.
Oh,
And
wow.
this top picture is zoomed out further, and it's showing the fiberglass that makes up the circuit board that the chip is made on. So you can see fibers going horizontally and fibers coming out towards you, and then we also made it thin enough that you can see a copper interconnect underneath. So these are just sort of some pretty pictures that show you some things that you don't actually need the SEM to see.
So this was something else that we talked about in class that we thought would be important to bring up here. Metal vias, the stacked vias. We saw several pictures of this throughout the course of the semester, and we were actually able to image these. So in the top, you can see something that looks really, I think looks really familiar. We saw a picture just like that way early on in the semester. And then this is a structure from the AMD chip, which you can't tell from this picture, but the silicon was cracked a little, so these are kind of bent. And then again, some more interesting features, and this is all metal in the AMD chip. So again, this is just an interesting example of how much metal there is in these chips and how complex the designs of each of these components are.
You can also note materials in terms of what materials are generally used for different interconnects, or what are what they use for connection from the interconnects to other features and other metal layers. They often use copper for interconnects and aluminum for transistors and tungsten connections between a lot of things, but there are a huge variation in different materials.
And then this image is actually taken top down on a Pentium 4, which was just cracked open. And what's really neat about this is you can see sort of the 3D layout of all these wires. This is the big bulk of silicon that you can see here that was left on the chip. And then these are the actual wire layers. And you can see there's like one layer here, then you can see another layer below it, some other chips of layers, and like a big hole. And all of this is wiring that's running in different directions, in different planes, and it's incredibly